in scientific notation, you always have to put your decimal place between the first and second or between the just to the right of the first non-zero digit.
So the amount of significant digits in the .7914, that doesn't matter whenever we're putting our answer in?
Well, what it means is that this one has 4 significant digits, and what you're looking for is the number with the least number of significant digits in multiplication and division. That makes sense? All right. Anybody else have any questions? Anybody else kind of fuzzy right now? Yeah. This is the correct number of significant digits, yes. All right, because this has 3 significant digits, and all the measured or calculated numbers, this one has the least number of significant digits. So our final answer needs to have that same number. And that's the rule for multiplication and division, yes.
Does it need to be written in scientific notation if we did that again, knowing you?
No.
It would just be
No.
.374?
0.0374.
I thought you said we didn't need a zero.
No, I'm sorry. What I was saying was the zero is not significant.
But we keep it in our...
Huh?
But we keep it in our answer?
Yes, because it's a placekeeper. It tells you the order of magnitude of this number. If you take out this 0 right here, you've increased the order of magnitude of this number by 1. You've basically multiplied this number by 10. And that's not the same answer, is it? So we want to keep the same value without for the answer. That's what we want. We can't change the value of the answer. That would be incorrect. It wouldn't be equal to this number anymore. I'm giving you too much information, aren't I? Yeah. Am I not?
I just don't see the purpose of significant zeros if we're not going to do anything with it.
Oh, we are going to do a lot of stuff with it.
Okay, so it doesn't apply to things like this? Okay. Never mind, just go on.
Okay. All right. Well, and while it seems a little vague and nonsensical right now, as we use them more and more, hopefully it becomes clearer and clearer why we have to do it. Okay? The number of significant digits is directly related to the precision of the answer. And we want to be clear about our precision.
And so we want to use the least amount of significant digits.
In multiplication and division, because we're multiplying by this number here, which is the least precise, we want to have the same amount of precision in our final answer. Yeah. Your final answer can be no more precise as the number in the problem with the least amount of precision.
Because in our notes it says choose the measured numbers in the problem and determine the significant digits in
Yep.
those numbers. Like it's the same number of digits. Like that's why.
Right. Well, that's kind of like the practical rule. Okay? That's how you figure it out. All right? The big rule is your final answer could be no more precise than the least precise number in the problem. Okay? That's a definition that almost nobody can actually apply until they've had a lot more experience than you have. Okay? So the way that you actually use that information is to pick the measured, by the way, you said measured number only, and it's measured or calculated number.
Well, I have calculated.
Okay, got it. I see. Okay. All right, so bear with me. We'll practice a lot and we'll get used to it. Okay, we'll be using this all semester long. Every time you do calculations in here, you've got to find the right number of significant digits. Fair enough? All right, so now that's the one-part rule. So that means that there must be some other kind of rule that's not just one part, and that's called the two-part rule. Well, that's what I call it anyway. I don't think I've ever seen a textbook that calls it this, but I like it that way because it kind of differentiates between one rule and the other. Okay, so the two-part rule states, or as I stated anyway, any zero, and we're talking about a zero digit here, any zero that follows, so since leading is to the left, following is to the right, okay, any zero that follows both, and here's our two-part, the both means there's two parts to this, okay, it has to meet both conditions, both, one, follows both a decimal place, both a decimal and two a non-zero digit. Now, I've got a grammatical error there in the question, but I think the key part is probably clear. Any zero that follows both decimal place and non-zero digit is significant. Got that? Anybody thrown by the grammatical error?
Can you show an example?
I'm going to show you lots of examples. Well, not lots, but some, yeah. Okay? All right, let's go back up here a minute. We said leading zeros are not significant. This zero, when I say follow, it means to the right, does not follow either a decimal place or a non-zero digit. That is to say, it's not to the right of any non-zero digits in a decimal place. So that zero is not significant. While these two zeros follow a decimal place, they have to meet both conditions. They have to follow a non-zero digit and a decimal place, and they don't. So these two zeros are not significant. That's why the leading zeros are not going to be significant.
So we would have to follow like the zero has to follow the one, maybe it has to be like behind decimal place.
Right.
Maybe like 0.1012, then it would be significant.
Well, let me give you a couple examples, okay? So let's say we wanted to make both these zeros significant here. All right? So let's take that number. So we can say it's 1.20400 times 10 to the 1, 2, 3, 4, 5, 5th grams of CO2. Okay? Writing the answer like this shows that these two zeros are significant. And they're significant because they follow a non-zero digit and they follow a decimal place. Okay? Now what if I only want to show one of those two zeros being significant? I'd put one zero and not two of them here. So it would be 1.2040 times 10 to the 5th grams of CO2. Okay? In this case, this zero is significant because it follows a non-zero digit and a decimal place. This zero is significant because it meets that rule too, but it also meets the one-part rule where it's between two significant digits. Yes?
So what if you had like 10.01?
Okay, good.
Would both zeros be significant because it's in between?
Yes, exactly. Okay, so this is the example he was giving. 10.01. Both zeros are between non-zero digits, and non-zero digits are significant. So both zeros are between significant digits.
So with the zero after, well, obviously after 10 would be significant.
I don't know if this is what you're asking me, but that's a good example to show you. Say we have 10.00 milliliters of H2O. Okay. All right. Let's take them. One step at a time. These two zeros here are significant because they follow a decimal place and a non-zero digit. Doesn't matter how far to the left they are. If it's to the right of that non-zero digit, it's following a non-zero digit. Okay. So both
only applies to the zeros to the left digit.
To the right of a digit.
I'm talking about like if it's to the left, it doesn't worry about it.
Yeah, if all you have are zeros to the left of non-zero digits, all zeros to the left are insignificant. They're leading zeros. Okay? So both these are significant, and because these two are significant, now this zero becomes significant. Okay? This zero becomes significant because it's between two significant digits.
How is the last zero significant?
The last one,
Yeah.
it follows a decimal place and a non-zero digit. It's to the right of a decimal place and a non-zero digit.
I'm just confused because I'm not putting 10 as a non-zero because there's a zero.
Okay?
We see what difference.
I know. You got to use it a while, okay? Because when you first hear the rule, it sounds either very confusing or very simple. But when you start to use it, wait a minute, wait. Now you got to think about the rules again, okay? So you just got to practice with them. All right? I'm giving her a chance. She's looking back at her notes to make sure she understands.
So on our homework, the first digit 0.0473.
Yes.
Is that zero significant?
None of the zeros in the number you just gave me were significant. Those are both leading zeros. Those are not significant.
Oh, I see. Okay. But if it was a 10.0,
Yes, then all the zeros are significant. Okay? All right. How many of your heads are just kind of swimming right now? Yeah. Yeah, it's kind of new. If you haven't had it before, it's like, OMG. Right? You got it now? Okay. Anybody want to just throw some numbers at me and let's play with them a little bit? Throw some numbers with zeros at me. No?
0.0056991.
Okay. And let's say that this is centiliters of CH3CH2OH. Okay? All right. This is really pretty simple because we can use the shortcut rule here. All of these are leading zeros. They're not going to be significant. Okay? Now if we were to apply the formal rules say these zeros are not between two significant digits, so they're not significant for that reason, nor do they follow a decimal place in a non-zero digit. So for both reasons, they don't meet either condition, so they cannot be significant. Does that make sense?
So
That's the formal rule.
say that 0 from the decimal was a 1.
Okay.
Would that make those two?
Okay, let's put that down here. 1.0056991 centiliters of ethanol. Okay. Now the two zeros are between two significant digits. They also follow a decimal place in a non-zero digit. So they meet both rules for being significant, and these two zeros are significant then. Okay? Anybody else want to throw a number at me? Or 2 or 3?
3.
Just the number 3?
No, I'm getting there.
Okay.
3, 0, 4, 0, 0.0057.
Okay. All the zeros in this number are between significant digits.
The paper.
Oh, sorry. All the zeros in this number are between significant digits. So all these zeros are going to be significant. Okay? Additionally, these two zeros follow both the decimal place in a non-zero digit. Okay?
What if there's a 0 on the end?
Right here?
Mm-hmm.
That zero is also significant. It follows non-zero digits in a decimal place.
But if that decimal was a comma, that 0 would be insignificant?
Ah, wow. We can't put the comma there. We can put, if we take that out right there and put the commas here and here,
That last 0.
now the last zero is treated as if it's not significant. Okay? Because we don't know if it should be or not. We have to assume it's not. Okay? Say what? All the zeros are significant because they're between two significant digits.
And you said you have to write what in scientific notation?
Okay, so this number here, suppose you want to make that zero significant. The only way to make that significant that you know of right now is to write it in scientific notation. And that's to say 3.040000560, okay, times 10, 1, 2, 3, 4, 5, 6, 7, 8, 10 to the 8th. Okay? Oh, I'm sorry, yeah. Okay, so for it to be scientific notation, your decimal place has to be just to the right of the first non-zero digit. Okay?